let's get right to the Engelberger Award. What does, I mean, it is such a high honor in the robotics field. What does winning an award like the Engelberger Award symbolize to you in terms of achievement or recognition?
Well, this is an award that I've watched great leaders receive over the decades, and um, I've never considered myself to be able to reach that level when I was younger. But I saw this award, and I see this award today as a prestigious example of people that are moving the robotics market in a very positive direction. It's a rare award to receive because there's so few people who can get it, and there's so many people who deserve it. And I am humbled to have received it. But I will say I stand on the shoulders of my employees at ATI who deserve, as a combined team, to receive this award alongside me. And I also stand on the shoulders of my customers, thousands and thousands of them who have supported me over the decades and who are my allies to this day because we have enjoyed serving them and they've been very supportive. So I'm very thankful.
Well said. Great, yeah, great answer. Certainly, can't get there by yourself, right?
Right.
Your interest in robotics, how did that begin? Was it something that was a childhood discovery for you, or was it something, in your career or in academics or even in your thanks for your service, by the way, in your military career? Was there somewhere along the path that robotics sparked an interest, or was it just always there?
Well, I got interested in mechanical items. I used to have when I was a very young man, when I was 11 years old, I got a paper route. And I told my parents that, I would support myself with this paper route. And that meant that I got a bicycle from my father. He was my venture capital supplier for this paper route. And I paid him back for that bicycle. And in order for me to make money on this paper route, I had to buy the newspapers. I had to buy the rubber bands, the plastic bags when it rained, and then deliver, and then go collect money once a week from the customers. It taught me a lot about business, but I had to keep that bicycle maintained because I didn't have any more money to spend on another bike. So I learned how to become a mechanic,
Huh.
and I really enjoyed it. And that got me very interested into mechanics in general for all kinds of devices. I came upon robotics shortly after I graduated from the University of Pittsburgh with a mechanical engineering degree. And I saw the opportunity to get into Lord Corporation to be in robotics. And I thought, what a fascinating mechanical device robots are.
Hmm.
They are the ultimate in mechanics.
What
And
year was this? Sorry to interrupt. What year was this?
so I got into Lord Corporation in 1980, in the robotics field in 1986.
Okay.
Yeah. And so that was how I got fascinated. I got fascinated through mechanical. I'm very fascinated about mechanical products, and robotics are the ultimate.
So, what about your time in the military? How did that time as a sergeant in the 82nd Airborne influence your career as an engineer or as a leader?
Well, yeah, I was in the 82nd Airborne. What I told my parents that I would pay for college, and then I realized, having made that statement, I didn't know how to do it. So one of my friends joined the army, and he recommended I consider it. And I said, well, what a way to make sure I can get my education paid for. And I joined the army, and I took a test, and I passed everything. And they said, you can have any job you want in the army. You've done so well on your test. I said, oh, great. What's the most dangerous job I can have? And they said, paratrooper in 82nd Airborne. I said, sign me up.
Wow.
And that's what I did for 4 years. And they promoted me to sergeant when I was 20 years old. Um, and I really learned a lot about leadership and how to lead people. And it influenced me in my career in robotics. Uh, uh, one example of that is I became very interested in seeing that everybody participate in um, in winnings. And what do I
Mm.
mean by that? Well, in a lot of companies, only the management gets bonuses. Well, I started a bonus program and I wanted every single employee to receive money. So it didn't matter what job you had, you received a bonus if we were successful. And, it's not that managers didn't receive a bigger bonus. They did because their salaries were larger. And they did have a lot of responsibility. But if you were a shop floor operator, um, you would also receive a bonus in a similar salary range for what you had. And and I believed in that because of my time in the service. It taught me how to treat everybody as much as possible equally.
So robotics, there's there'll always be amazing marvels of machine engineering in their
Hmm.
own right, but and they've kind of become almost components within industrial equipment now, just because of the way that they're integrated into equipment for different applications. What are some of the more intriguing examples of robotic integration that you've seen in machinery or in work cells?
Well, as far as the most interesting, first of all, there is nothing better than walking into a large automotive plant with 1,000 robots in motion. It's like watching an orchestra. So
Right.
I'll never get past that as one of the most fascinating things to watch. Having said that, going beyond that, I would say our work with JPL on the Mars rover. People might not know this, but the Mars rover has a robotics laboratory inside the rover. So when
Really?
they get rock samples, the rock samples are brought into the laboratory and moved into test tubes, and those test tubes are then moved into containers on the idea that those containers one day will be brought back to Earth. We were able to get a force sensor onto that Mars rover arm. It took us 7 years of engineering, but we got a sensor developed for a force sensor for the Mars rover, and it's on there today working. And one of the proud moments, but also one of the more unique robotic applications. And then the other one that comes to mind is robotic surgery. The fascination of using robots, you know, in a surgical atmosphere. It's some people can get very nervous about it, but the lesson I've learned is that robots can be perfectionist. Um, they are deadly accurate. And one example of this is a researcher showed me a long time ago how they could take an eye of a person and they would blow it up onto a screen. So the eye was the size of 3 feet. And then they says, now we can take the robot into that simulated eye and I can see the smallest detail. And I have the refinement to be able to work on that eye 3 feet wide instead of three, I don't know, 1 millimeter, right?
Right.
So the bottom line is that robotics has played a unique role in a variety of applications. The great thing about ATI with our robotic tool changer and force sensors, we are on any robot we can get our hands on. It didn't matter the application.
Hmm.
So I can tell you, if I wasn't on them, I wanted to be on them.
Right.
Yeah.
Certainly. Yeah. Yeah, like we said before, end effectors really have changed the way, I mean, robots are, axes and they have the ability to move into places, but really what they do is dependent upon whatever that gripper or whatever the end effector is on the end
Hmm.
that allows it to do whatever it's doing.
Yes.
So one of the other developments in robotics of recent years has been collaborative robots or cobots.
Hmm.
And one of the intriguing things that, at least to me, that I've noticed is, there's also been this perceived push toward autonomous manufacturing. With that push toward autonomous manufacturing, will the collaborative ability of a cobot become redundant and unnecessary just because there will be no humans in an autonomous manufacturing facility for the cobot to collaborate with?
It's the collaborative robots that are doing more with physical AI than the industrial robots. The reason that is that uh, collaborative robots can work closer with people. You still need safety guards, but collaborative robots have a dual redundancy to them and they have additional safety factors. So they can work closer with people. And so you can put these robots in closer proximity. In addition, there are new safety features, and again, uh, physical AI might play a role where if people are getting too close to the robot slows down. And then if people get even closer, the robot will stop automatically until the people leave the area and the robot will resume. This allows people to walk in, do work with the robot, walk out, and let the robot complete the task. And so right now today, collaborative robots are the most popular robots for physical AI. I was reading a FANUC earnings report, and they made it quite clear that they saw that their CRX collaborative robot as a key to very strong sales in physical AI.
Sure.
And then in addition, ABB just announced a new robot line, all collaborative, that has physical AI. So that's the market right now that is hot for physical AI. It doesn't mean in the future that industrial robots aren't going to become more popular with physical AI, and that you don't need the additional safety factors. But what's clear today, the way the market is shaping, it's people and robots. It's not just robots.
Hmm.
And that's the way I see it going on for quite a while. This
Hmm.
whole idea of a dark factory, an autonomous factory, I think uh, only works in super repetitive, high volume type work. Um, but what we want robots to be able to do is to be flexible to do high variety of work.
Hmm.
And so that idea of these factories that are producing, 100,000 cars, every quarter. And what we want robots to get to is producing 1,000 pieces of variety off of a manufacturing line, which could be components for, say, a refrigerator, or a component for air conditioner, and you can run it on the same line.
Right.
And that's where physical AI really takes off. We don't need as much physical AI for the highly repetitive work.
Hmm.
We're doing that today. It's
Right.
what we're not doing today is what we need these robots for.
Sure. So it's enabling that flexible engineering capacity where the robot can make the decision to produce one widget versus another, or just has the ability to change its end effector and become a robot that does a different kind of application.
And has the flexibility to slow down or stop, let people come in, do work. The robot then analyzes that work, inspects it, and goes, okay, now I know my next job because of what I see.
Absolutely.
That's
Yeah.
high flexibility. And
Right.
that, you know what? Most, you don't see that today. That's, and so because you don't see it, you don't perceive that it's coming. So,
Right.
but this is what is coming. This is
Right.
the high flexibility we've all been wishing for.
Right. In fact, there are a couple presentations that are going to be taking place at Automate in Chicago
Mhm.
this June that actually talk about some of the integration of some of these other technologies, AI and vision technologies, a variety of sensing technologies that are enabling robots to get closer to making those kinds of decisions as well.
Absolutely. In fact, NVIDIA has sponsored the humanoid pavilion at Automate. And, when you hear the word humanoid, people go, oh, I don't think humanoids are something we should be really interested in. not the kind of robots that I see being okay. When you hear the word humanoid, replace humanoid with physical AI. And
Right.
physical AI can work on any robot.
Yep.
So the humanoid pavilion and the humanoid conference that comes with it at Automate is the physical AI pavilion, the physical AI conference. And that is where you're going to see those solutions.
Right. Yeah, it's going to be a very exciting time at Automate this year. It always is, but especially
It's
this
going to
year.
be it's going to be a record-breaking Automate, and it's going to be the most interesting demonstrations in history.
Right. Yeah, I totally agree. So, okay, let's talk about you and your business career as well a little bit.
Mm-hmm.
Scaling a hardware company from zero to over $100 million, certainly no small task. What was what was the most significant technical product redesign, say, that
Okay.
ATI had to make in order to accelerate growth?
All right. I got to go deep into the past,
Okay.
and I'll talk to you about an incident that occurred. Um, Around 2003, we got a job for a robotic tool changer to help a tier supplier that supplied General Motors. The robot was picking up very heavy parts, and we got a phone call saying, "Hey, your tool changer is gapping as the robot is moving, and it's allowing electrical circuits to be disconnected, which we don't want. We need you to fix it." So we went out there, and I said, "Hey, guys, this robot is really moving very fast with heavy parts. The tool changer has a moment restriction. It can only handle so much moment. And normally, in normal applications, it should be able to handle this weight, but you're accelerating it too high. And so let me get an accelerometer on it. The accelerometer measured 8 Gs of acceleration. And 8 Gs of acceleration is the kind of acceleration that people will pass out and possibly
Sure.
be injured. I said, the first thing I told him, I says, you can't run this robot at 8 Gs and have it survive,
Right.
and all the tooling underneath it, because they were not only breaking, or the tool changer was not only separating, but the tooling underneath it was breaking.
Wow.
So and so the customer said, "No, I'm sorry, but I'm not slowing it down. You need to fix this." I said, "Okay, what are my parameters for this tool changer? I have to invent a new tool changer." I said, "What are my parameters?" He said, "Okay, the parameters are I want the same stack height. I don't want it to weigh any more. You can make it a little larger, maybe on the diameter, and I need it to be a drop-in replacement." I said, "Oh, thanks for the uh, uh, for the great specifications there."
Right.
So I went back to the engineers, and I was really flummoxed. I said, "This customer insists we have to do this, or we're gone." They just won't use tool changers because, believe me, no competitor could handle this application. They just were going to probably give tool changers up,
Hmm.
and I didn't want that. And this was the
Right.
future of our company
Hmm.
at stake. This is a couple over 2 decades ago. And so engineering says, "Give us a few days." They came, and I told them, I said, "We don't have much time here." They came back at the end of the week and they said, "We found a solution. Um, we'll have to redesign the tool changer from scratch, but it'll be 3 times stronger when we're finished." I
Wow.
said, "That sounds pretty neat." We didn't even have time to prototype because the customer was so anxious. We went straight into production with this new design,
Wow.
went to the customer site, and all of that gapping stopped, period. Tool
Really?
changer was rock solid, 8 Gs of acceleration with heavy duty parts. And that invented a new tool changing line, our heavy duty tool changers, which became the most popular tool changer in the world.
Wow.
Yeah.
What a great story.
And those engineers, I can't tell you enough how proud I am of the work that they accomplished. And they literally reinvented the product and brought ATI back up to speed.
You were talking earlier about, the people whose
Yep.
shoulders you have stood on, and talking about sharing the bonus with people in different parts of the organization, and that's a great example of it right there, where you got your team together, your engineers, and said, "We need to do this," and you relied on them, and they came through for you.
And I will say, General Motors toured the plant a month after our new tool changers were installed, and General Motors was so proud of what they saw from our team that we became the General Motors standard back in that day.
Wow. The success of ATI, certainly um, well documented,
Hmm.
which led to acquisition. Uh,
Yes.
and then certainly that's a big change, moving from being a founder-led company to a Novanta business unit. And that certainly had a great deal of impact on you, I'm sure. For the engineers on the ground, how did you help to maintain that culture of innovation, like you were just talking
Hmm.
about, while adapting to, obviously, in a bigger company, you have more standardized processes that
Yep.
you need to abide with. So, how did you help to make that change with your group of engineers?
Yes. It was a culture change. In the past, the way I would run the company is if I saw an opportunity, I didn't follow budgets. I would just go get the money and spend it. And then a public company doesn't work like that.
Right.
And you have to budget for the year. And I never did that before. So I had to learn how to budget, and I had to learn, and we, the employees, had to learn how to live within that budget. And it's not like we couldn't ask for more money if an opportunity came up, but it was a process. It wasn't my decision. It was something that had to be thought through carefully and slowly, before it would happen. So speed slowed down, and I would say we became more careful with our money. But what I learned is when you have a budget and you're more careful, you learn how to spend it more wisely. So you look at what you're spending, everything you're spending it on, and you don't waste. So what the public company taught me was how to uh, be more frugal and make the most of what I had.
All right. So, shifting gears a little bit too, then, as an advisor, you talked a little bit about physical AI earlier. As an advisor on physical AI, uh, how do you see the role of those mechanical engineers changing as large behavior models begin to take over path planning and manipulation?
Well, there's going to be a lot of I would say increased need for engineers, because what physical AI is doing for robotics is opening up a lot of Pandora's boxes, and all of a sudden new applications are coming out of the woodwork. That's going to require a lot of engineering, a ton. So AI actually is going to make work so much more intense. Sure, it's going to help the engineers solve problems. It's going to do the opposite though. As far as replacing them, it's going to make them even more valuable, and we're going to need to educate a lot more, because every new job that a physical AI opens up and creates, we're going to need a mechanical engineer on top of it to engineer the hardware that surrounds it. So we are going to benefit. We're not going to need robotic programmers like the way we have today.
Right.
Instead, we're going to need robot solution providers that understand the big picture solution needed and the engineering behind it, and we'll let the robot autonomous robot figure out the path planning and all of that. So it'll save us time in some areas, but because of the just the increase in work, there's going to be more to do. So an integrator today, you know, let's say is producing $20 million worth of work. That might come out between, say, 20 jobs. There's no reason with physical AI where you couldn't double that, where
Hmm.
that same integrator could produce 40 jobs. His revenue won't necessarily double because the amount of work necessary to do the extra jobs, he's going to be more productive.
Right.
This will be a lower cost for the manufacturer. They can pay less for the automation, but there'll be more to automate,
Yeah.
and that will require more engineering.
Yeah, certainly the roles of engineers in all careers are being impacted by AI of all types.
Mm-hmm.
And certainly, just I think you're absolutely right in just the way that you look at the job that you're doing or the career that you're in. It's not necessarily going to be eliminated. It's just going to change. Where
Mm-hmm.
what the AI is able to do just removes that portion from you, and your role expands rather than shrinks. So so in an increasingly adaptive robotic world, does that demand for extreme mechanical precision still remain, or will software-defined compliance make high-spec hardware less critical?
It's actually going to be a combination of both. I have found that AI can handle, uh, you know, lower tolerances,
Mm.
and AI can do more with less. Um, a lot of people will tell me, for example, on vision, we don't need a 3D vision camera because AI has been able to pick up through 2D cameras the amount of information that you can get out of 3D.
Really?
That's what I'm being told. And so for that reason, rather than having an expensive 3D camera, we'll do it with less expensive 2D cameras. One of the companies that you can look at for this kind of information is RealSense. It's the old Intel company that does cameras and vision.
Okay.
Their cameras are selling like hotcakes in this new AI world. AI can do more with less, but the reason I said both, it'll open up a lot more new applications, and many of those new applications will be high precision.
Mm.
There are just certain areas where precision is going to be critical. AI will help, but it won't reduce the need for that precision.
Right. So just like it changes engineers' career focus, it changes the industry as well, right?
Yeah, it increases the amount of work that the industry can perform.
Right, absolutely. So let's get back to ATI for a second. So
Hmm.
in a highly competitive high tech market, right? You moved ATI toward 50% employee ownership. Again, going back to
Yep.
knowing the value of the people that work for you and with you. How did that ownership structure impact the retention that you had of senior engineering talent, for example?
Well, our attrition was one of the lowest in the industry. It was around 1% attrition. And the people who did leave left on extremely good terms. Um, Sometimes it was just plain simply retirement. Other times the opportunity that they received was really, really, really good. I mean, I had one employee leave for SpaceX. I mean, I can't beat SpaceX.
Right.
It's a great company.
Sure.
So when we had people leave, they left for a really good reason. And I always left the door open for these employees. Some didn't like, where they went, and they came back. So I always had an open door policy. If you left on good terms, you had a job back at ATI if you
Wow.
wanted it.
Sure.
And some people took us up on that offer.
Wow.
So extremely low retention rate. Um, just any employee specs that you want to look at, workman's compensation, for example, we had enormously low injury rates, extremely high safety. Um, Employee satisfaction was extremely high, and so it made the company more valuable because the customers actually got the results of this.
Hmm.
There's
Sure.
nothing better then when our employees would go into a factory to help with a problem, and the customers would then contact me and say, I don't know where you got these people from, but they're the nicest, most dedicated people we've ever met. And they've been so friendly with the staff here, trying to solve a problem that was partially our fault, partially your fault, maybe, you know. And I was like, absolutely, it doesn't matter whose fault it is. We're there to help, and
Right.
and our employees got it. I mean, they really understood customer value. So I partially credit the ESOP for helping bring that together, but I really need to give as much of the credit to the people who actually did it. I think, honestly, they would have done it with or without an ESOP. The ESOP just was an extra special thing.
So now, as an A3 board member, uh, I know we've talked a lot about AI, but what technology besides AI do you think will be impacting the robotics industry? Maybe not vision
Yeah.
either.
Yeah. And I would say I've watched vision just become increasingly more credible
Sure.
and faster and easier to use. But I also see the same thing happening in force sensing.
Ah,
So force sensing is going to follow in a similar shadow of vision, and it's becoming less expensive. It's becoming easier to use, and it's making robots be able to make better decisions. So I see that as one of the areas of future growth. Um, and You see it in robotic surgery today. For example, Intuitive Surgical put a force sensor on the end arm of their robot.
uh,
And what they're finding is new things are starting to appear, new ideas of how these robots can be used. That because vision was only getting them 80% of the way, but that force sensor was like a third eye, and it was
uh,
starting to feel things and give that feedback to the surgeon. And then all of a sudden, the surgeon was able to make decisions vision was not helping them with.
really?
Yeah. So I see force sensing as one of the areas of growth that goes beyond AI.
Yeah, that's very interesting. That, unintentional, certainly, but um, yeah, definitely, yeah, something I would have never even because and did that's come about just because of the work that you've done with that and the interaction and just
I'll
something
leave
that
Intuitive Surgical to say that they did that on their own.
okay.
Okay, that one on their own. We have helped other surgical companies with force sensing, and they've shown similar results. But Intuitive
Wow.
Surgical, um, fantastic engineering on their own.
That,
I think one of the keys is, I am seeing that there's just more variety in end effectors. Um,
hmm,
you know, as time has gone on, we've gone from just a hand select of types of end effectors. I'm seeing a lot of interesting new technologies come out of vacuum, for example, um, uh, where the cost of the valves that control each of the vacuums, they can make these vacuum end effectors with multiple heads. Each one is in control. So when it goes down to pick up a box, it only turns the vacuum on the suction cups that are touching the box, and the ones that are not, it stays off.
hmm,
And the technology has always been there to do that, but the cost has never been made it a good idea till
right.
lately. Now I'm
Uh-huh.
beginning to see, this vacuum technology become better and better. I was talking to uh, the president of Schmaltz USA, Volker Schmidt,
Okay.
just yesterday, and I said, "What kind of work is Schmaltz doing with humanoids?" He says, "Well, we built a vacuum pump that only runs on 24-volt and a battery.
Hmm.
So you can put this pump into a humanoid and run it off of the humanoid's battery.
Wow.
And it's a low cost much easier way to handle when you don't have a power connection. So it's interesting. I think these humanoids in physical AI, but humanoids are helping us create new uh, uh, end effectors. And Schmaltz's battery operated vacuum is just an example. Some of the actuators that I'm seeing being designed are quite remarkable. They're very low weight, they're very high power. Um, and there, a lot of these actuators are being developed by the humanoid companies themselves, not just the outside companies. I mean,
Right.
just at Novanta, we've been working on new servo drives specifically with safety in mind. And
Huh.
I do see safety as a one of the big drivers today for end effector development. And so these new servo drives have built-in safety features that weren't there before, specifically put in to help robots like humanoids to be able to produce the ability. If a humanoid, for example, shuts down quickly, catastrophically, you want the servo drives to take over and say, we need to go into safe mode. And then all of a sudden the servo drives indicate, what has to be done in order, what is safe mode,
Hmm.
that has to be decided. And
Right.
so that might mean that the humanoid collapses slowly and carefully in place instead of dramatically wailing around
Hmm.
and then um, throwing itself onto the ground,
Right.
um, which you have seen in some videos.
Sure. Of
Uh,
course.
so I think the bottom line is that the variety of end effectors that's coming out today is at a much higher rate of engineering than I have ever seen.
Hmm.
And that's because of all the venture capital going into building these new robotic devices. Humanoids being obviously one, but only one of many.
Right. Absolutely. Well, Bob, thanks so much for taking the time to talk with me. Congratulations again on
Thank you.
your being awarded the Engelberger Award. Such a great honor. I mean, obviously very well deserved.